Okay, so we've got a train engine, we're given its mass, and it's pulling a carriage along a straight horizontal track. It's carried by a shunt, which apparently we can model as a light rod. So that means if it's light, it means that the tension will be the same throughout of it. And if it's a rod, it'll be inextensible, so acceleration will be the same for the carriage and the train engine. We're given the driving force of the train, and there's resistance forces working on both the train and the carriage, and we're given the acceleration. So the first thing we want to do is definitely sketch that out. So I'm going to have mine travelling off to the right. So there's a 12,000 Newton driving force. This is my train engine, which has a mass of 6,400 kilograms. The carriage has a mass of 1,600 kilograms. There's tension in the shunt, and because it's light, those two values of tension will be the same. The train engine has a resistive force of R, so that's the one I'm not told, and the carriage has a resistive force of 2,000 newtons. Okay, and the first thing I must find is the value of R. So to do that, I'm going to need to model the whole thing as a single body, because if I just try and look at the engine, I've got two unknowns. I don't know R, and I don't know the tension, so I won't be able to do anything with that. So I'm going to just combine the whole thing as a single body with 12,000 Newton force pulling it along, and a 2,000 Newton and R Newton's forces holding it up. And I don't need to worry about tension because they are equal and opposite, so they will be cancelling each other out. So I will need to add the two masses together though, and altogether that is an 8,000 kilogram train. So, and I know that it's accelerating, tell me the acceleration, it's accelerating at 0.5 meters a second squared. Okay, so if I use F equals ma, so I'm taking right as positive, so the total force is 12,000 newtons, and then that's going to be minus the resistive force of 2,000 minus the resistive force of R, and that's going to equal the total mass of the train times the acceleration. So if I do 12,000 take away 2,000, and then minus the 8,000 times 0.5, which is 4,000, that will give me R of 6,000 newtons. Then I'm asked to find, I'm asked to show that the tension in this shunt is 2,800. So good thing about show that question is I'll know if I've got the answer right, but I do need to be careful that I clearly show that I have got it. But obviously if they've given me the answer in the question, I'm not going to get anything just for 2,800. I will need to clearly show where that's come from. So I could look at the carriage or the engine. I'm going to look at the carriage just because that's got less forces on it. And if I look at the engine, I've got to consider three forces, plus if my value of R is incorrect, that's going to then follow through. So either would work, but I'm going to look at the carriage. So the carriage has a mass of 1,600 kilograms. It's been pulled along by the tension in the shunt, and I was told that there is a resistive force of 2,000 newtons. So if I use, it's travelling off to the right. So if I use F equals ma, and I'm taking right as positive, that's going to be T minus 2,000 is mass times acceleration. So that's going to be T, it's going to equal 800, and then plus that 2,000. So T, it's going to be 2,800 newtons. And I could double check, I could look at the train engine and double check that works. Let's just check those answers. Lovely.